What if that faint, shimmering band you sometimes see across the night sky isn't just a distant glow, but a colossal empire of billions of suns, our very own cosmic home? In this episode, we're not just looking at the Milky Way, we're diving into its heart, exploring its hidden structures, and discovering how this vast galaxy is both our origin and our destiny. From the dark valleys of Earth, the Milky Way rises as a soft, luminous river across the summer night, a pale band too delicate for city skies but older than the continents beneath our feet. To human eyes, it appears fragile, a faint arch of dust and light. To science, it is an empire of hundreds of billions of suns spanning 100,000 light-years. It is our home, our island in the cosmic sea, and our first laboratory for understanding what a galaxy truly is. Long before telescopes, this ghostly band stirred mythology. The Greeks imagined it as milk spilled from Hera's breast. The Norse saw the pathway of warriors bound for Valhalla. The Maya named it the White Road of the Gods. Only in the 17th century, when Galileo turned his telescope toward that shimmer, did humanity learn what it really was? Countless stars too faint and crowded for the unaided eye to distinguish individually. Today, we know that the Milky Way is a barred spiral galaxy, a flattened disk of gas, dust, and stars twined into sweeping arms that coil outward from a central bar of older suns. Viewed from the side, it appears thin, only about 1,000 light-years thick, but vast in diameter, roughly 100,000 light-years across. If the solar system were reduced to a single grain of dust, the galaxy would be an arena larger than the continent of Asia. At the heart of this disk lies the galactic bulge, a dense swarm of ancient stars packed into intricate orbits surrounding something even stranger, a supermassive black hole known as Sagittarius A. It has a mass of about 4 million suns compressed into a region smaller than Mercury's orbit. Radio astronomers at the Event Horizon Telescope captured its shadow in 2022, a donut-shaped halo of light surrounding darkness, the signature of matter spiraling toward oblivion. This object anchors the Milky Way's rotation, holding the galactic core together through its immense gravity. It is the hidden heartbeat of home. Surrounding the bulge stretch the spiral arms, the Perseus, Carina Sagittarius, Norma, and Scutum Centaurus arms, along with smaller spurs and bridges of star-forming regions. Our Sun sits within one of these minor lanes, the Orion Arm, a short segment tucked between the larger Perseus and Sagittarius arms, about 26,000 light-years from the center. From this vantage, we peer outward through dense clouds of gas and dust that dim and redden distant starlight, shaping the mottled glow we call the Milky Way. Within those arms, stars are born. Dense knots of hydrogen collapse under gravity, heating until nuclear fusion ignites. Bright blue giants illuminate surrounding clouds, carving spectacular nebulae. The Lagoon, the Eagle, the Trifid, nurseries where newborn suns wreathe themselves in ionized gas. Over millions of years, these giants live fast and die in cataclysmic supernovae, scattering heavier elements, carbon, oxygen, iron, that enrich future generations of stars and planets. Every atom of calcium in a human bone, every molecule of oxygen we breathe, was forged by such stellar deaths. The Milky Way is not merely scenery, it is ancestry. If you could view the galaxy from far above its plane, you would see the luminous spiral pattern slowly rotating, though rotation is a simplification. Stars nearer the center orbit faster than those in the outskirts, yet the arms themselves are not rigid structures but density waves, patterns of crowding that move through the disk like sound through air. Stars enter an arm, drift through its richer gas, then depart, leaving the pattern itself to persist. Our Sun is about halfway along its 225 million-year orbit around the center. It has completed only about 20 laps since its birth 4.6 billion years ago. Each revolution reshapes the sky of every planet it carries. Beyond the disk lies the galactic halo, a sparse spherical cloud of ancient stars and globular clusters, tight, glittering spheres containing hundreds of thousands of suns bound by gravity. These elders date to the dawn of the Milky Way, over 12 billion years old, fossils from the era when the galaxy first condensed from smaller proto-galactic fragments. The halo also hides an invisible component, inferred not by light, but by motion: dark matter. Galactic rotation curves show that visible mass alone cannot account for the speeds stars maintain at great distances. Something unseen, perhaps 10 times more massive than all the stars combined, creates an extra gravitational pull, enclosing the galaxy in an unseen sphere. Though its nature remains mysterious, this dark matter scaffold holds the Milky Way together, shaping every orbit within it. If you're finding this journey through our galactic home as captivating as we are, consider hitting that subscribe button and joining us for more explorations into the universe's grand designs. But if our galaxy seems like a stable, ancient home, what if I told you it's actually a cosmic cannibal, constantly growing by devouring its neighbors? What hidden scars and ongoing battles reveal the violent, dynamic history that shaped the Milky Way into the home we know today? Our understanding of the galaxy has grown sharper thanks to missions like the Gaia telescope, which since 2013 has been charting the positions and motions of more than 1 billion stars with exquisite precision. By tracing their trajectories, scientists have reconstructed the Milky Way's history, revealing that it grew through collisions. Roughly 8 to 10 billion years ago, a smaller galaxy dubbed Gaia Enceladus merged with ours, its stellar remnants still visible as looping streams across the halo. Even now, the galaxy continues to feast. Astronomers watch as we slowly absorb the Sagittarius dwarf galaxy, its tidal debris draped like ribbons around our disk. Galaxies are not static cities. They are ecosystems in perpetual evolution. Inside the Milky Way are diverse neighborhoods shaped by age and chemistry. The thin disk, where we dwell, is rich in metal-bearing stars born from recycled stellar material. Above and below it, the thick disk and halo harbor older, metal-poor populations, relics of an earlier universe when heavy elements were rare. These metallicities tell a story of ongoing creation. Each generation of stars adds complexity to the next, forging the elemental alphabet from which planets and life emerge. The Sun's position affords a vantage at once humble and privileged. We see neither the galactic center's blinding radiance nor the deep emptiness of the outskirts. We orbit through a zone of relative calm, far from frequent supernovae, yet close enough to observe the galaxy's architecture. From this perch, both danger and discovery coexist in balance. The Milky Way does not live alone. It belongs to a local group, a gravitational family of more than 80 galaxies spanning 10 million light-years. Our nearest companion is the Andromeda Galaxy, roughly 2.5 million light-years away, faintly visible as an oval mist to the unaided eye. Between them lie smaller partners, the Triangulum Galaxy, and a host of satellite dwarf galaxies such as the Magellanic Clouds, irregular systems that orbit like bright sparks caught in a slow gravitational dance. Astronomers predict that in about 4 billion years, the Milky Way and Andromeda will merge, their stars passing harmlessly through one another while their mutual gravity reshapes both into a single, enormous elliptical galaxy. The night sky then will blaze with millions of unfamiliar suns, and the concept of Milky Way will merge into a new, larger identity. It is sobering to realize how little of our galaxy we can actually see. Dust lanes woven through the disk obscure 30% of its starlight. Infrared and radio telescopes pierce these veils, mapping regions invisible to optical eyes. The central molecular zone where new stars ignite, the long bridges of hydrogen stretching beyond the arms, the subtle warp of the outer disk induced by gravitational tides from dwarf companions. From these observations, a portrait of astonishing complexity emerges. The Milky Way ripples, bends, and breathes like a living organism. Our galactic motion threads the concept of time once more. The Sun races around the center at 828,000 kilometers per hour, dragging Earth and its companions along. Meanwhile, the entire galaxy itself hurtles through intergalactic space at 1.4 million kilometers per hour relative to the cosmic microwave background. To be alive within it is to ride layers of motion stacked beyond comprehension. The spin of Earth, its orbit around the Sun, the Sun's orbit around the galaxy's drift toward Andromeda, all nested like gears in a cosmic machine. Humanity's relationship to the Milky Way is slowly shifting from wonder to cartography. We no longer merely look at it, we measure it. By counting variable stars known as Cepheids and mapping radio emissions from hydrogen at 21 centimeters, astronomers refine its three-dimensional shape. New surveys using infrared satellites reveal regions where stars are clustering along newly recognized armlets, suggesting that our classic four-arm model may simplify a subtler pattern. Each incremental map brings the galaxy into clearer focus, yet each revelation also underscores our smallness within it. And yet, for all its immensity, the Milky Way is only one of roughly 2 trillion galaxies in the observable universe. To grasp that scale is to feel paradoxically closer to home. Our galaxy is neither giant nor dwarf, neither exceptional nor insignificant. It is an archetype, a common form through which the universe expresses order. Its structure, rotation, and star formation echo those of countless others scattered across space. In studying the Milky Way, we study a mirror of cosmic evolution itself. The aesthetic beauty of our galaxy remains undiminished by analysis. On a dark night far from artificial light, the band overhead still stirs ancient awe. Across deserts, mountains, and oceans, it ties every watcher into a single frame of belonging. Behind that faint glow lies depth beyond knowing. Billions of stars we will never visit, and within them, perhaps, billions of worlds that will never know us. But the same physics, the same light, binds us together. To be human inside such grandeur is to oscillate between humility and exhilaration. We are one small consciousness riding a single planet around one small star among hundreds of billions, yet capable of understanding both the origin of our galaxy and its eventual fate. Science has not diminished wonder, it has quantified it. The numbers, light years, masses, velocities, are not the death of mystery, but its modern vocabulary. In the next episode, we will leave this stellar island to explore our position within the larger family of galaxies, the local group, and onward to the Virgo supercluster, to see how the Milky Way fits into the broader architecture of the cosmos, and how gravity weaves galaxies themselves into dazzling webs across the universe. If you've been awestruck by the majesty of our Milky Way, make sure to subscribe for more incredible journeys through the cosmos. And to continue your exploration of the universe's wonders, click on the video appearing on your screen right now.